welcome back to my channel Cat by Nagendra. So in this tutorial we are going to create this butterfly valve assembly part designs along with that assembly design in SolidWorks. Now just first we'll start here with this first part. So here dimensions of body. So for this body we are having one top view. For that they have given here sectional front view and they have given side view. Now let's create this first body part. So I'll go here with new part. Let's say okay. Now to start this, I am going to start from top because we are having here circular portion, or else in front view also we can create only half section and we can make it here revolve boss. So let me start here with this two circles, one with radius of 140 and one more with diameter of 194. So I'll go for sketch on this top plane. Let me draw here two circles. Inner one diameter we are having here 194. Outer one we are having radius of 140. So diameter will be 280. Exit workbench. Isometric. We'll make here extruded boss. So on both sides we can make it at a time, or else half section we can do and we can make it mirror also. So now I am going to make it here total entire thing. Total this height we are having here 225. Let's make it here 225. Let's say. Then next to that we are having here the small supports. So with this shape. So for that just I'll go for sketch on this top face. Make it normal. Now to create that shape, for outer curve we are having here radius of 50. Then for this curvature we are having here, you can see properly it should be with these dimensions. So just I'll go for dimension and I'll make it here this shape. This curvature dimension we wanted here, but here they have not specified. So for that we can make it here with reference to this dimension we are having 175. So you can take this curvature radius as 175. So let me create one center point arc, or else directly we can give the dimension of 175. So we need here radius of 50 circle, then here straight lines exactly on this horizontal axis. So I'll select this. We'll convert into like entitles. Then by using line, just I'll start somewhere from here. One horizontal line, go forward and come backward. You will get curvature directly. Then one more horizontal line like this. Go for trim. I will trim this. We don't want these things. Again, this also I will trim. Then relation between this point to this, we need here horizontal relation. Dimension for this curvature we are having radius of 50. Dimension from center point to this we are having here 170. So like that we can make it this one. Along with that we can create these holes also, or else later we can go here with the holes. So that is our fish. Then so let me complete in this step itself. I'll draw one more. This diameter we are having 47. Then in sketch itself we can make it pattern, or else later also we can make it pattern. So later we will do. So exit sketch, will make this extrude boss in reverse direction downside. This height we are having here 32. Let me give here 32 we want. Let's say okay. Same thing, this boss extrude total we need here 3 in circular motion. We can go here with circular pattern. With reference to this circle, total we need 3 with reference to 360 degrees. Let's say okay. Then by holding control, just we will select this boss extrude and this circular pattern. We'll make it here mirror with reference to this top plane. As we have used mid plane properly, this top plane will be at center. Directly we can make it mirror like this. Then next to that, here extra material we are having. If you see section view, here extra material is added. So here this one we don't know how much dimension is there. So you can see from center we need here a distance of 160. From here it should be with a distance of 160. So for that, we don't have any proper support here to draw one sketch at a distance of 160. Here two methods we can use. First method is, whatever this profile is there with the circle shape, that circle shape you can draw exactly here on this center, and you can make this extruded boss of 160. At the end we can create this hole. That is one method. One more is, with this distance we can create one offset plane. Later we will draw the shape and we will make it extruded boss up to next. So now we are going to create that reference plane lengthy process only, because we will be used with different type of options. Now this profile should be exactly opposite to this horizontal one. So I'll go here with reference plane. With reference to opposite to this we want it. So we'll select here right plane. In this reverse direction, flip offset with dimension of 160 we want it here. Let me give 160, let's say. Now on this plane we'll go for sketch. Make it normal. Again make it normal. Now exactly at center point, this outer circle we are having, which is having diameter of 200, material should be added up to next. Let me create one circle here exactly at center point with a diameter of 200. Exit sketch. Isometric. We'll make this extruded boss up to next. Why? Because we are having this curvature. So if we make it up to next properly, it will align to that. This plane we can hide. Same similar to that. Opposite side also we are having. From here with the distance of 325, we want this circle diameter of 75. So again I'll go here with reference plane. From here in reverse direction with a distance of 325. 325 we want. Okay. On this plane go for sketch. Make it normal. We need one circle here with a diameter of 75. Exit sketch. Isometric. We'll make it here extruded boss. Same here also up to next. And let's say okay. This plane also we will hide. Like this. Then next we can go here with directly holes. So here also one center hole we are having. You can see here counter bore type hole is there. Now this counter bore diameter we are having 100. Counter bore depth we are having here 25. Normal hole diameter we are having 56.2. Depth should be 310. You can see up to here only material is removed. Now we need one hole, so we'll go for hole wizard. With our own dimensions we can go for legacy hole. Here we need counter bore type. Counter bore diameter we are having 100. Counter bore depth we are having 25. Normal hole diameter is 56.2. 56.2. Then depth, if I try to change it won't come. Why? Because already we mentioned end condition as up to next. We'll make it blind. Now this depth should be 310. Double click. We need here depth of 310. Go for position from this face exactly at this point. Origin point. We need to get fully defined. Let's say okay. Properly that hole will be created up to whatever the dimension we given. Then next to that, here again three holes are there with a diameter of 20.3, three places with a depth of 15 on exactly 150 diameter BCD, base circle diameter. Means these three holes should be exactly on this construction circle diameter of 150 with a diameter of 20.3. Now directly I'll go for hole wizard. Diameter we need 20.3. Depth we need here, they mentioned depth of 15. So let me change here 15. Position from this face, let me make it normal. I'll keep it somewhere here. So here it should be exactly on vertical like this. relation between these two we need here vertical relation. Then BCD they given 150 diameter. If we want we can create one construction circle and we can make it coincidence, or else directly we can give dimension here. Diameter is 150, radius will be 75. Fully defined. Let's say okay. Same hole total we need here 3 in circular direction. So circular pattern with reference to this, and let's go. So like this, if I make cut section, we will be able to see that section front view also. So in this simple way, we can create this particular part. I'll turn off this section. Now let me apply some color for this. So on part, we'll go for appearance for this particular part. We'll apply some color. Okay, then we can save it. So we'll go back to assembly. Here we'll create new folder. So we are going to create here this butterfly valve assembly. I'll open butterfly valve. So first part is body. Let me make here name as body and let's save this. And just I will close this part. Then next we are having here this shaft. So for this shaft directly we can create this half section. We can make it revolve boss. Later we can remove this extra material. Now again I'll go back to here SolidWorks new part. On the front plane I'll go for sketch. Then this half section we need to create here. Only this half section we are able to draw. I'll go for line from here, one horizontal, then this step we wanted, then straight to this we want, then one more with length up to the center. Let's close this. Now we'll go for dimensioning. Dimensions, as you can see, this upper one we are having here 87.2. From this to this we need here 87.2. As we created only half section we need to make by 2. Then next to that down one we are having here 56. So this to this we need here 56 by 2. Then this small one we are having here 37.5. For this we are having here 37.5 by 2. Then this one also should be equal to this. So let me make it here relation between this to this. We need relation between this line to this line. We'll make it here collinear. It will become straight to that. Now we'll go for horizontal dimensions. Starting we are having here 28.9. This is 28.9. Next step we are having 89.8. This is 89.8. Then next we are having here this overall length. This is 24. So let me move like this. And we need here distance of 24. Then remaining thing. So this entire thing we wanted here. So separately they have not mentioned. So just we will add this 193.8 plus this 38.2 plus 15.1. So this we wanted length. We need here this 38.2 plus 193.8. So 38.2 plus 193.8 plus this 15.1. Like this. Then exit sketch. Make it here revolve boss with reference to the central axis. Let's say okay like this. Then we need here this cutout. So that cutout I'll go for front plane. I'll make it normal. Just I'll create one rectangular profile here. Dimension for this we are having 15.1 gap. Then this dimension we are having 31.1. From bottom to this we need here 31.1. This length we know this directly 193.8. So we need here 193.8. Exit sketch, isometric. We will make here extruded cut by using here mid plane on both directions at a time like this. That cut will be removed. Then chamfer we are having at edge with 3 into 45. So we'll go for chamfer only for this one. Edge we need here dimension of 3 and let's say okay. Then at last we'll go here with this two holes which is having diameter of 12.5. So exactly from this face we need hole diameter of 12.5. Then depth should be up to next position from this face. I'll make it normal. So directly we'll create here two holes. For that dimensions we are having here from this edge to this center we are having 46.9. From this edge to this point 46.9. Then this to this we are having 100. So this hole to this hole we are having 100. Then we'll apply relation between this point to origin point. We'll make it horizontal relation to get fully defined. Let's say okay. So that is about the shaft. Let me apply some color for this and let's save this. Okay. Then we will save as shaft. Like this we can create this first two parts. We'll go here with this retainer part. So to create that again we'll go here with new part. Let's say okay. Now to create this retainer just we can create this circle which is having diameter of 200 and it should be made here extruded bus of 25. Then holes are there. So for example on the top plane I'll go for sketch. I'll create one circle which is having dimension of diameter 200. Let me give here diameter of 200. Then exit sketch, isometric, extrude boss. So this extrude boss of 25. Let's make it here 25 and let's say okay. Then one center hole we are having here with the diameter of 56. We'll go for hole wizard, legacy hole with the diameter of 56. Then depth should be up to next. We'll go for position from this face exactly at this origin point and let's say okay. Then again here with a diameter of 20.3, total 3 holes are there and these 3 holes should be exactly on 150 BCD. So now again I'll go for hole wizard. Diameter we are having here 20.3, depth up to next. Go for position from this face, we'll make it normal. Now exactly with reference to this origin, we'll make it one on vertical. Relation between these two, we will make it here vertical relation. Then BCD they given here 150. So this is the diameter of this position 150. So instead of giving diameter and instead of creating circle, directly we can mention here as 150 by 2, radius 75. Let's say okay. Same hole, total we are having here 3 holes. We can go here with circular pattern with reference to this. Let's say okay. So let me apply some color for this by using appearance. Okay, then we will save this. So here this is a retainer part. So whatever the part name is there, better we can give the same name. Why? Because while calling into assembly it will be very easy, and while creating bill of material in drafting also it will be very useful for us. So whatever the part name they have mentioned, same name we need to provide. Then next we'll go here with arm. So we are having here top view, then section front view. So this is here outer circle diameter we are having 112.5. Then this outer circle diameter we are having 87.5. So at a time we will create this. It should be make here extruded bus of 62.5. Now new part on the top plane. We need here two circles. Then again here two circles. Relation between this center point to this center point, we need here horizontal relation. Then dimension for this outer circle we are having 112.5. Dimension for this inner circle we are having radius of 28.15. Then again this cutout also it is there. So for this circle, let's say OK. Mouse right click. We need here display as radius of 28.15. Then rectangular cutout we are having here with this height of 12.6. Let me draw one rectangle here like this. By using trim entitles, we will trim this. Then relation between this line to this line will make it equal. Then this height we are having here 12.6. Length from this center point to here 35. From center to edge we are having here length of 35. Then for this circle we are having diameter of 87.5 for outer one, 87.5. Then for inner one we are having here 43.8. Dimension between center to center we are having 300. Let's give this length from point to point we need here 300 like this. Then in single step also we can do like here again we can draw two lines and we can make it in a single step, or else one more step also we can do. Let's go here with two steps. Extruded bars by using mid plane. Total height we are having here 62.5. Let's say OK. Then again on the top plane, why? Because that extra material we needed exactly at center. So exactly on top plane we'll go for sketch, make it normal. Then just we needed these tangent lines. For that it should be a closed profile. So instead of drawing circles, again we can go here with convert entitles. Just we will convert that existing circles. Then just I'll create one line here. Relation between circle to line we need tangency. This circle to this line we need tangency like this. Go for trim. We don't want this. We don't want this here. Same line we need on opposite direction. We can create one more, or else we can make it mirror. Again to make mirror we need one horizontal for construction line like this. Then mirror this with reference to this center line. Let's say OK. Again go for trim. You can trim this inside ones or outside one. So I'll trim this outer one only. Material will be added exactly with that inside part. Extruded bus by using mid plane. So this total material should be at center 25 mm. Let's give here height of 25. Let's say OK. Like this we can create this arc. Let me apply some color for this by using appearance. Okay, we will save this as arc. Close it. Then again next we can go here with remaining parts. So let me create here first a plate. So if you observe here, usually we will think this is a circular part, but for circle we will be having diameter or radius, but here they have given two different dimensions. So here vertical dimension is there, horizontal dimension is there. So here we are not having circle, we are having here helix shape. So on the top plane I'll go for sketch. We need here ellipse, not circle. We are going to use here helix like this. Semi major axis, semi minor axis. Then dimension from center to this, vertically we are having here 102.5. Dimension from this to this, horizontally we are having here 96.9. Then relation between this to this, we need here horizontal like this. Then along with that, we can create here these two holes also, which is having diameter of 12.5 exactly on this horizontal axis. So we need here one circle like this, one more circle here. Then relation between circle to circle, we will make it equal. The relation between this center to this center to this center will make it horizontal. Then diameter for this we are having 12.5, diameter of 12.5. Difference between hole to hole distance we are having here 100. Separately we can create with hole wizard, or else directly we can create. Why? Because in a single step it will be finished and we are not having any special holes here. So to make proper fully define, I'll give the central dimension, exit sketch, isometric, extruded boss by using this mid plane. So total this thickness we are having 6 mm. Let's say okay. Then again I'll go here with appearance for this particular part. Let's say okay, then save it. So we'll save it as plate. Then I'll close this. Again next we can go here with nut, hexagonal nut. Again new part. On the top plane, I'll go for sketch. We need here hexagon, which is having 6 sides. Total, we need here 6 sides. I'll keep it like this. Then dimension for this nut, we are having end to end 69. So line to line distance, we need here 69. Relation between this to this, we need here horizontal. Then again at center, we are having diameter of 37. I'll create one circle here with a diameter of 37. We'll make this extrude boss by using this mid plane. So total height we are having here 25. So every time why I am maintaining mid plane means this axis system will be exactly at center. In case if you want to make relation with reference to center in assembly design, so easy to access from here. Then this radius of 10 mm cutout is there. This is not fillet. So to create that cutout, on which plane we'll be having here maximum dimension, this end diagonal point to point, on that plane we need to go for sketch. So here possibility is we can draw on right plane or front plane, but if you draw on right plane, sketch will be created somewhere here. So we won't remove, like we will be not able to remove material properly. So only we'll go for sketch on this front plane, make it normal. Then just I'll go here with convert entities. We'll convert these two edges. Fillet we want for this edge with radius of 10 mm we wanted. Let's say okay. Then by using trim entities, we'll trim these unwanted elements. So this curvature also removed. Let me go back. We need here corner. Here dimension each fillet. Let me trim this. These lines we wanted. So this end to this end line we want from, we need to make it as a closed profile. So just I'll create this relation between these two, we need tangency. Between these two, we need tangency. Exit sketch, isometric. Then we need to remove material here with rotation by using here revolve cut. Central axis is, we don't have any central axis here. So let me try to select this circle. We'll be not able to select. In such cases, we can go here with visibility. Then show here this temporary axis. So with reference to this central axis, we need to remove material like this. Properly material will be removed. Later we can turn off that temporary axis. Then let me apply some color and let me save this part. Okay, save as nut. Let me close this. Then last part we are having here screw. So to create this screw, just we can create off section and we can make it here revolve bars. On the front plane, I'll start from here. Later this cutout we can done. So from here, one horizontal, one vertical, then one more horizontal. From here we need this curvature. So I'll go forward and come backward straight to this like this. Then dimension at bottom we are having 20. So as we have created only half, we'll make it only 10. Then this length we are having here 38. Then radius we are having here 15 like this. Now if we try to move this, it will be moving. Let's check this dimension also. So this is done and this also we have given. We don't have any extra dimensions here. So according to that, this center point should be exactly on this vertical axis. Make it here coincident. Then exit sketch, isometric, revolve bars with reference to this central axis like this. Then later we need to go here with this cutout part which is having here width of 4 and height from this edge we are having here 3. So again I'll go for sketch on front plane, make it normal, just we'll create one center point rectangle here. Then this rectangle should be upside like this. Dimension from this edge to here we are having here 3. Then this width we are having here 4 mm. Let's say okay. Then exit sketch. We'll make it here extruded cut by using mid plane, like we need to remove material on both sides. Let's say okay like this. Then at end we are having here chamfer of 3 mm. So we can go here with directly chamfer for this edge with dimension of 3 we want, and let's say okay. Then just we can go here with again appearance. Let me change some color for these two. Okay. Then we will save it in the same folder as screw. So just I'll click on save and I'll save it as screw. Already I have saved this. Then we can close it. Now we'll go here with this assembly design. So to create this assembly design, first I'm going to call this first body part. Now new, we need to start here with assembly design and let's say okay. Reasons insert component, we need here body. Then let me make here rotation with reference to y direction and keep it here. Then next we are going to insert this inside shaft part. So for that, insert components, we need here shaft. All parts at a time we can insert into assembly design, but it will be confusion for us to select the parts. Better we can go with step by step like this. Just we'll keep it somewhere here. Go for mate. Both we are having here cylinders. We can make it here axis to axis or circle to circle concentric relation. Then this should go inside. So one thing you can mention, this end should be attached with this inside edge, or else this flange profile, this part, it should get attached with this one. Just will make it insert like that. So it will be similar to this. Then still rotation will be there for this particular part. If we make parallel with reference to any this face, we will be not able to see this plate, this inclination. So what we are going to give here is, we are going to keep it here inclination like this. Now mate we want, angle we need, like relation we need between this face to, I'll open this body, I'll select this front plane, we need here angle relation, angle mate, I will make it here some 45 degrees like this. You can see it is going properly here with inclination. Let's say okay. Later if you want we can adjust that angle also. Then next I'll call here this inside plate. Insert components, plate we want, open that, keep it somewhere here. Directly I'll go for mate. We need relation between this hole to hole, this hole to any hole you can select. Let's say okay. Let me drag that part out. Then this hole, it should be attached with this hole. Okay. This face, it should be attached with this bottom face. Let's say okay. So in SolidWorks, in a simple way, we can complete assembly design. Just we have assembled that plate to that shaft. Then next we need here this retainer part. So insert components. We will go here with retainer. Open that. Then just we will keep it somewhere here. Now we need mate between this cylinder to this cylinder like this. Let's say okay. Then to make proper alignment, I'll make this hole to this hole to lock rotation like this. Then this face, it should be attached with this side face. Let's say okay, like this. Now as you can see, entire thing we got fully defined. Then next we will go here with this arm. Insert components. We need to insert this arm. Let me keep it somewhere here. Then we'll go for mate, relation between cylinder to cylinder we want. Let's say okay. Then this face, it should be attached with this face. Let's say okay. Then same here also, it should be with inclination as they have shown here. So what we can do here is this inclined face, already we given inclination for this one. Directly we can make it parallel to that. How much inclination we have given for this, same it will be created here also. Let's say okay. Now let me adjust that 45 degrees into 30 degrees. Here also we are getting some error with reference to these two. Let me go back by using Ctrl plus Z. This angle mate I'll edit. Angle I need only some 30 degrees. Sorry, 60 degrees I will take. Let's say okay. Then we need relation between this to this. Okay. Then this face should attach with this face. Okay. Then this to this angle also we can give. So this one to this front plane, we will make it here inclination of 60 degrees. Let's say okay. So let's check whether our mates are correct or wrong. So if any error is there with reference to this mates, this entire thing it will highlight in yellow color or in red color. So there we will need to modify that. Next we will insert this nut here. So we'll go here with insert components. We need nut. Let's open that. I'll keep it somewhere here. We need mate between this cylinder to this cylinder. We need in reverse direction. We can make it here flip mate. Let's say okay. Then this face, it should attach with this face. Okay. Then to lock rotation, already we are having here flat faces. So this face to this any face, we can make it parallel. And let's say okay. Now entire thing we will get here fully defined up to here. Then at last we are having here these screws. Insert components. Again here you can see yellow color it is highlighting. So extra some mate is overlapping. So just let me go back. So relation problem is with reference to this nut. Let me apply a relation between this to this. Okay. Then this face should attach with this face. Okay. This face with reference to this I'll select, or else on top also we can select to make it parallel relation. So we'll try in one way like applying mates. So if we are getting any error, we need to try to change that selection of faces. So again we got here fully defined. Here no error is showing. Again insert components. We need here at last this screw. Open that. I'll keep it somewhere here. Now, made between this cylinder part to the cylinder part, we need in reverse direction. Let's say okay. Now it went inside. Let me drag that out like this. So if it is inside and if you are not able to find that, so just you can go here and screw. Just you can click this. It will be highlighting inside. Or else this entire part, mouse right click on the body, mouse right click. We can make it here. Change transparency. Then easily we are able to drag that out. Later again we can go on body. We can turn off here. Change transparency like this. Then mate between this face to this face. Okay. Then to lock this rotation, here also we are having flat face. This face to this face, I'll make it here parallel like this. Then no rotation will be present for that. Then directly we can create one circular pattern. Again you can see error is there. So some extra relation here it is highlighting. Let me go back. Let me apply again relation between this to this. Concentric is there. This face to this face. We need coincidence. Then this flat face to any this flat face, I'll make it parallelism. Let's check any error is there or not. So here nothing is there. Then same screw we need here for this 3 holes. So we can go with pattern, but here we will get underdefined. So instead of that, we can go here with copy with mates. Go for next. We need concentric to this, coincide to this, then parallel to this flat face we have given. Directly I'll come here with parallelism like this. Then let's say okay, this coincident relation with reference to this. Okay, same repeat. I'll repeat this. We need here concentric to this. First concentric relation for this, then coincide to this face, parallel to this face. Let's say okay, then attend we need to cancel. So these are the parts we have created, and this is the butterfly valve assembly. Like this we can create single individual parts and we can make it assembly design. So I hope you have understood about this butterfly valve assembly, and I hope you are understanding my videos. So if you really like video, please like the video and share to your friends to whom it will be useful. And maximum people simply they are watching and they are leaving. Please, if you really like video, please subscribe to my channel and keep supporting. Thank you so much.